Geometry students, today is one of my absolute favorite concepts from geometry, and it actually has big implications in Algebra 2 and higher levels of math. And it's really about usefulness. I just think it's beautiful too. Let's start with an equilateral triangle. What do we know about triangles that are equilateral? Well, we know if they're equilateral, then they're equiangular. So what do we know about all these angles? We know they're all 60 degrees. So I'm going to drop an altitude here. It shouldn't be hard to prove that if I drop an altitude, that I have a right angle here and a right angle here. I have a congruent side, I have a congruent side, I have a congruent angle, I have a congruent angle. So I've got angle, angle, side congruent to angle, angle, side. So these two triangles are congruent. So I know this angle here is congruent to this angle. So I know this is 30 and I know this is 60. The other thing is I know that this side here, call it x, is congruent to this side here. So that would also be x. And then because the big triangle is an equilateral triangle, I know that this whole side here would be x plus x, which is 2x. Now if I just draw the 30, 60, 90 triangle, I have that this is 2x, and I have this angle is 30, and I have that this is x. So already I have an interesting fact about 30, 60, 90 triangles. And that's the side opposite the 30-degree angle is always half the hypotenuse. Go ahead and type on your calculator sine of 30 degrees and you'll get 1/2. That's because the opposite side divided by the hypotenuse in a 30, 60, 90 triangle will always be a ratio of 1 to 2. So I've used that fact in many physics and other trigonometry problems already, and now you know that. And that's part of this here. The next thing that I think is exciting is just using what we already know to be true about right triangles. That a squared plus b squared equals c squared. If I just do the algebra here, I get that x squared plus b squared is equal to 4x squared. Notice algebra, 2 times 2, x times x. I now subtract the x squareds. I get b squared is equal to 4x squared minus x squared, which is 3x squared. I then take the square root of both sides, and I get that b is equal to the square root of 3, which is not a nice number, and the square root of x squared, which is simply x. And so I know that in any right triangle, any 30, 60, 90 triangle, the side opposite the 60-degree angle is the square root of 3 times the side opposite the 30, or it's half the hypotenuse times the square root of 3. So I know an exact value for the cosine of 30. The cosine of 30 degrees is actually the square root of 3 divided by 2. That's an exact value, and I don't have to use a calculator to get some decimal equivalent. I just take the adjacent side, x root 3, and divide by 2x, and I get root 3 over 2. So from this slide, what you need to actually know and commit to memory is the following. That if you have a 30, 60, 90 triangle, that the side opposite the 90 degree, if we call it 2x, then the side opposite the 30 degree is x, and the side opposite the 60 is x root 3. And now I should be able to give you one of 3 different pictures. I could give you this picture where I tell you this is 30 and I tell you this is 5. I could give you a little bit more difficult of a picture where I tell you this is 30, this is 90, and this is 14. Or I can give you the hardest picture where, one, I flip it around, so one, it's hard to see that way. And I say that this angle here is 60, and I say the side opposite this is 4. So now just knowing the relationship on the left here, I should be able to find all the missing sides. How would you do that? Well, in this problem, if this is 30 and this is 90, I know that's 60. I know if the side opposite the 30 is called x, I can say this side is x. So the hypotenuse is 2x, and the side opposite the 60 is x root 3. Now I have these three sides, and I don't have to do any algebra to do it. Over here, I know if I have this is 30 and this is 90, this is 60, I have the hypotenuse, so that's 2x. That means x is equal to 7, so the 7 goes here, and that means this is 7 root 3. The hardest one is when you have the side opposite the 60, because now you know 4 is equal to x root 3. You solve for x and you get x is equal to 4 divided by the square root of 3. You know that's not how we like to leave numbers in math, so we rationalize the denominator, calling this 4 root 3 over 3 because I had multiplied both sides by root 3 over root 3. Now that's what x is. So I know this side opposite the 30 is 4 root 3 over 3. And then the last thing to do is double that to get the hypotenuse, so this is 8 root 3 over 3. This is actually something that shows up on the SAT over and over again, and kids always want to know when they're going to use it. Well, you will use this to get into college, and it's called a 30-60-90 triangle, and you're going to use it in Algebra 2 when you study trigonometry. So you want to know that. Similar to how we derived a 30-60-90 triangle, I want to derive the other special right triangle from a square. What do we know about a square? Well, we know all the angles are right angles, and we know all the sides are congruent. And if I draw a diagonal, it should not be hard to show that you have side angle side congruent to side angle side. So these two triangles are congruent. So I know this is 45 degrees, and I know this is 45 degrees. And so now if I draw what we call a 45-45-90 triangle, I also like to call it a right isosceles triangle. If I call this side x and I call this side x, I can call the hypotenuse c, and I can do exactly what I did in the last problem, and I can solve for the hypotenuse using the Pythagorean theorem. So I get 2x squared equals c squared. I take the square root of both sides and I get c is equal to the square root of 2, which is not a nice number, and the square root of x squared, which is x. So this is equal to x root 2. And just like we did in the last problem, you can now write down this 45-45-90 triangle, or what I like to call a right isosceles triangle, x, x, and x root 2. Similarly, you can do the problems. There's only two problems that you can do here. One problem will look like this. I tell you that this is a right isosceles triangle, and I tell you this is 8, and you go, well, if this is 8, this is 8, and this is 8 root 2. That was easy. And if I tell you this is a isosceles right triangle and this is 9, well then what you're going to do is say 9 is equal to x root 2, divide both sides by the square root of 2, get x is equal to 9 over root 2. We don't like that, so we rationalize the denominator and get 9 root 2 over 2. And that's what each leg is, because the legs are congruent and both of them are 9 root 2 over 2. Your classwork tomorrow is just going to be doing a ton of problems where you know you have one side of a right triangle and you know it's either a 30-60-90 or a 45-45-90. Have a good night. Peace.